Hello and welcome back to Mr. Butler Maths. In this video we're looking at multiplying fractions. As always, if there are any other particular topics you'd like me to cover, please leave a comment. I think this is an important topic because lots of people know how to do it. They know the process of multiplying fractions, but they don't really know why they're doing it. So in this video I'm going to calculate the area of a shape with a height and length that are both fractions, but I'm going to do this just by looking at the shape itself rather than doing any multiplication. And this is going to provide a visual explanation of why we multiply fractions in the way that we do. To start with, we're going to start with a square of 1 centimetre by 1 centimetre. The area of this square would be 1 centimetre squared, because to find the area we multiply the length, which is 1 centimetre, by the height, 1 centimetre. So the area of this square is 1 centimetre squared. I'm now going to split this shape into 6 equal parts. Each part will be 1/6 of the total shape, and the area of each part will be 1/6, because it's 1/6 of the whole shape. All of those 6 added up together would give us the area of the whole square, which is 1 centimetre squared again. Now I'm going to shade in 1/2 of this square. 1/2 of this square is equivalent to shading in 3 of those 6, as we can see in the diagram. I'm also going to shade in 1/3 of this shape. 1/3 of this shape would be equal to 2/6, so 1/3 is 2/6. Those two fractions are equivalent to each other. Now if I take just one of these little rectangles, 1/6, that's going to have a length of 1/2 centimetre, because its length is half of the whole square, and a height of 1/3 of a centimetre, because it is 1/3 of the whole height. So the area of a rectangle with a length of 1/2 and an area of 1/3 is 1/6. I know it's 1/6 because it's 1/6 of the whole original square. If we now remember back to finding the area, when we find the area, we multiply the length, 1/2, by the height, 1/3. So 1/2 times 1/3 must be equal to 1/6. I know this just from looking at the diagram. I haven't done any multiplication at all yet. This is all just inferred from this diagram. I know the dimensions of this little rectangle, and I know the area of this little rectangle is 1/6. So 1/2 times 1/3 must be 1/6. And this is a good illustration of our method for multiplying fractions. Now, the procedure for multiplying fractions, we multiply the numerators together, and then we multiply the denominators together. 1 times 1 would give me 1 as my numerator in the answer, and 2 times 3 would give me a denominator of 6. So 1/2 times 1/3 is equal to 1/6. Now let's look at a slightly different example and talk through that one. So starting in the same place but with slightly different fractions involved. So I'm starting with my 1 centimetre square again. This time I'm going to divide the whole shape into 8 equal parts. So the area of each part will be 1/8 of the area of the whole square. So the area of each little rectangle in this square is 1/8 of a centimetre squared. So this time I'm going to start by shading in 1/2. This time 1/2 is equivalent to 4/8. And I'm going to shade in 1/4. 1/4 is equivalent to 2/8. Now if I want to multiply 1/2 and 1/4 together, let's break down my square into a smaller rectangle, which is going to have a height of 1/2 centimetre and a length of 1/4 centimetre. So the area of that little rectangle is going to be 1/8 of a centimetre squared. That must mean that 1/2 times 1/4 is also equal to 1/8, because that's how we find the area, by doing 1/2 times 1/4. Now let's check that this makes sense with our method for multiplying fractions. Numerator times numerator 1 times 1 gives us 1, and denominator times the denominator, 2 times 4 gives us 8. So using our method by looking at the area, we've provided a visual explanation of why we multiply fractions in this way. Now, when you're looking at these, and when you're multiplying fractions, you don't have to always draw out the square and shade in the different parts, but it's important to know why we multiply fractions in the way that we do and where that comes from, and that's what I've hoped to show in this video. Look after yourselves. Thanks, guys.